Hi, and welcome to this introduction to QGIS or Qgis. This is a video for the absolute beginner, but if you are used to another GIS, this video will also give you a quick introduction to the basic functions of Qgis. The video is quick-paced, and you will almost certainly need to pause it at times in order to keep up, if you want to work along with the instructions. Before we get into the practical stuff, I need to inform you on some theoretical nonsense that you don't need to know to get started, but you need to know something about it to understand why things may not be as straightforward as you might first expect. First of all, GIS is a vast and complex subject. After all, you can spend years at college learning about it and still just scratch the surface. This video will not make you a GIS pro. It will, however, give you enough knowledge to create your own maps for fun, for your community, or even for a small business. One of the main reasons for the complexity is that we try to twist real-world data into something that makes sense on a flat computer screen or a paper. A lot of the science stuff is taken care of by Qgis, but it will have consequences in the work we do. For instance, when we try to show large areas of the round Earth flat on the screen, things will get distorted. And depending on what we want to do with the result, we may need to compensate for this in different ways. This is really important if we, for instance, want to measure distances and areas in an exact way. Qgis is open source software and free to use in any way you want. The maps you create are yours to do with as you please, as long as you respect any data provider's terms of usage. You can freely download and install Qgis for Windows, Mac OS, or Linux from qgis.org. On the webpage, you can also find news, documentation, reference for users and developers, as well as resources for the Qgis community. Qgis is free to use, but it is encouraged to support the project, and you can do so in many different ways. From now on, I will assume you have downloaded and installed Qgis on your computer. I will be using Qgis on Linux with English as the GUI language, but it shouldn't matter much because the GUI looks very similar on all platforms. When you first start Qgis, you will see a pretty simple interface with a menu and buttons at the top, some panels to the left, and a big area in the center right. At the bottom of the window, there's a status bar with information and some input fields and tools. As you can see in my version, there's a colored text to inform me that a new version of Qgis is available. I'm going to use version 3.4 in this video, and depending on what version you are using, things may look or work slightly different. But you should be fine even if you are from my future and are using version 3.18 or even newer versions. Just to get started, we are going to add a simple world map. Find the coordinate field in the status bar and type in world and press enter. We can now start to work with an actual map. Use the mouse wheel to zoom in and out of the map. If you want finer control of your zooming, you can press the Control key on your keyboard while scrolling. If you want to pan the map, just press down on the scroll wheel and move the map. There are dedicated buttons and tools for panning and zooming, but I find the scroll wheel convenient and it always works even if you have a different tool selected. There are useful buttons like Zoom to Full, but that, like so many other tasks in Qgis, can also be achieved by a keyboard shortcut. In this case, Ctrl-Shift-F will zoom the map to the full extent. Let's just get some more of the science stuff out of the way. In the lower right of the window, you can see a symbol with a text that says EPSG 4326. This is the projection of the map, which is the method Qgis uses to stretch the world to a flat surface. You can change this projection by pressing the area where the text is. There's a lot of projections to choose from, and not all will work for all projects. For now, you could try type 3857 or pseudo Mercator in the filter field. Select the row with EPSG 3857 and click OK. This will change the look of your map, but also its properties. As you move your mouse around the map, you can see the numbers in the coordinate field change. These numbers represent the mouse cursor's position in the selected projection coordinates. If you change back to EPSG 4326 or WSG 84, you will see that the numbers change too. If you have a national coordinate system or projection that you want to use, you can search for it here. You can, for instance, look for a UTM projection for your area of interest, which is better suited for local map work. If you are on the northern hemisphere or north of the equator, type in 326 in the filter, and if you are in the south, use 327. Then scroll down until you see a list of projections that start with WGS 84. Try clicking on one and look at the preview of the area suitable to use the projection for. Find the projection for your area and apply it to your project. UTM is not suitable for large global areas. It will require you to zoom in a lot to make sense. And then we probably need some more data. In the panels to the left, there's a browser panel. This is a resource tree with your local file system, connected network resources, and other defined data sources. In the list, you can expand some areas, and if you look under XYZ tiles, you will find one online data source predefined. It will require that you are online, but otherwise, you should be able to just add the OpenStreetMap data source directly to your project. You can do this by right-click, drag and drop, or double-click. Now you can continue to zoom in more closely on your map. You must, however, remember that you may have a local coordinate system selected. If you don't want to worry about that anymore for the remainder of this video, you could switch to the Sudor Mercator or EPSG 3857 projection. If you look at the Layers panel, you should now have two layers there, the initial World layer and the new OpenStreetMap layer. You probably can't see the World layer because it is underneath the OpenStreetMap layer. If you want to change the order of the layers, just drag and drop the layers in the order you want them. Sometimes it can be tricky to place a layer at the top, but then you just right-click it and select Move to Top. You can turn the visibility of a layer on and off with the checkbox for that layer. So, let's start to be creative. Find a location with an area of water, maybe in your local community. Before we continue, we should save our project. Click the Save button, use the menu, or simply use the Ctrl+S keyboard shortcut. Find a folder location and save your project with a suitable name. In the top of the program window, the project name will now be visible. Let's close Qgis and start it again. Your recent projects will be presented in the main window as recent projects. You can either open them by double-clicking on them here, or use the Open Project button or menu. But you can also use the browser to find the project file you saved and open it from there. For this project, we should now create some of our own custom layers. Data comes in a lot of different formats, but Qgis has made it easier to work with a few of these. First of all, there's raster data and vector data. The OpenStreetMap layer is a form of raster data, and the world layer is vector data. They behave differently and have different properties that can be manipulated. In this video, we will only create vector layers. To start with, click the button New Temporary Scratch Layer. This will open up a simple dialog where you give the layer a name and select a geometry type. For the first layer we will create a layer called Land and select Polygon as geometry type. The rest of the settings do matter, but for now they are not important and can be left as default. One thing about temporary scratch layers are that they are just that, temporary. If you close your project for any reason, the data that is in that type of layer will be lost. But it is a convenient way to experiment and work with intermediate data layers. As soon as you create the layer, it will be in edit mode. You can see that by the pen icon on the layer symbol, and that the toggle editing tool button is pressed. You can toggle editing for the selected layer on and off by pressing this button. You can only edit the data in a layer when it is in edit mode. Now select the Add Polygon feature tool and create your custom island. Every click with the left mouse button will add a point to the polygon called a vertex. If you make a mistake, you can remove the added vertex by pressing Delete or Back button. When you are done, you press the right mouse button. This finishes the polygon and you can start adding another one if you like. To edit the shape of a polygon, you can use the Vertex tool. To select a vertex, you hover over it and click the left mouse button. Now you can move it to a new location and click again to place it there. You can also click on a segment to select and move it in the same way. To add a new vertex on a segment, just click the plus sign visible on the segment when you hover over it. You can select one or several vertices by click and drag. You can then move them all together the same way, or remove them by pressing Delete or Back on the keyboard. Save your edits by pressing Save Layer Edits and toggle editing for the layer off. Do you remember that this is just a temporary layer? So let's make it permanent. In the Layers panel, you can see a chip symbol at the temporary layer. One way to make the layer permanent is to right-click it and select Make Permanent. Another is just to click the chip symbol. You can save vector data in a large number of formats. But for this video, we will be using the default GeoPackage format. First, you browse to a location where you would like to save your layer and give the package a file name. Then you name your layer and press OK. Now your island is stored permanently in a GeoPackage file. Let's make it pretty. Make sure the layer is selected in the Layers panel. Then click the Styling Panel button or just press the F7 key on the keyboard. It is possible to make simpler style changes directly from the Layers panel and more complex in other ways, but the most convenient way is with the Styling panel. The default is a single symbol, which is fine for this layer. Lines and points will be styled differently, but we will get back to those later. For now, you can change the layer color and transparency, but you can also select one of the presets if you like. When you select different presets, you can see that the contents in the style list changes. You can build your own style in this list manually and save that as a template too. For now, just select a template that is a simple color and select the simple fill line in the style layer list. This will show the detailed properties of a simple fill style layer. Try experimenting with the fill color, line color, thickness and stroke style. Note that you get a different color selector depending on if you click on the color patch or the drop-down arrow. If you want to, you can pick a color from anywhere on the screen. Also note that colors can have transparency. Transparency can also be set for the entire layer in the layer rendering settings. In the Style panel, you can also style a label for the polygons in the layer. These can also be of different types, but a single label is fine for now. To create a label, you can type a text inside single quotation marks in the Label With field. Just type in Island in the field. We will change this later. Now you can experiment with the font settings, and for now you can also check the buffer and shadow settings. You can also look at the placement settings and try to find something you like. There are a lot more settings, but that is for another video. You may want to use different names for the islands. The best way to do this is to store additional information for the polygons in a table. This table is already created, so all we have to do is to edit some columns in it. Select the land layer and hit F6 on the keyboard. You can also right-click the layer and select Open Attribute Table. Attributes are what the information about our polygons are called. Each attribute has its own column in the attribute table. You can have as many columns as you'd like, and to start with, there's only one column with a unique object ID. Toggle editing for the layer on by pressing the pen button in the attribute table toolbar. Click the New Field button and type in the field name Name. Also select the field type as text. You can define the size of this text field to limit the reserved space for data. But if you leave it at the default, it will adjust automatically. Now fill in a name for each of your polygons. Save your edits and toggle editing off. Then you can close the attribute table. If you have an object selected, you can deselect everything with the Deselect Features button. To use the individual names on your islands, you select the land layer, go to the Styling panel and the Label settings. There you select the name field instead of the island text. Now each of your polygons should have the name you created as a label. Try to add a new island with the editing tools to see if you remember how. Also remember that you finish your polygon with the right mouse button. This time you will get a form to fill in when you are done. That is because this is now a permanent layer with associated attributes. Just fill in the form and ignore the ID field. Now it is time to save your project. If you look at the title bar of the program, there will be a star by the project name if there are unsaved changes in the project. When the project is saved, you should start a new project by pressing the New button, selecting New from the project menu or hitting Ctrl-N on the keyboard. This will give you a new empty project to work with. Use the browser and locate the GeoPackage you created for your land layer. Expand the GeoPackage and add the land layer to the new project. As you can see, it looks nothing like what you created before. That is because style is not saved with the layer data as standard. Normally, style is saved in the project file, but if you want to use your data in different projects, you might want to style the layer only once. Open the previous project again. You can discard the newly created project. To save the layer style with the layer data, you will need to go into the layer properties. You do this either by right-clicking the layer and selecting properties or by double-clicking the layer. The layer properties dialog have a lot of property settings, including the style and label settings. For now, we are only interested in the style button at the bottom of the dialog. Click it and select Save as Default, followed by Data Source Database, and that's it. Now you can try to create a new empty project again and add your layer to it. It should appear with the saved style settings. Save this new project with the name Treasure Island. To create the illusion of water around the island, we will create a duplicate of the land layer. Right-click and select Duplicate Layer. This will not create a copy of the data, only a new layer in the layer panel. The new layer will still point to the same data as the original layer. Rename the copy Ocean by selecting it and pressing F2 on the keyboard. Activate the layer and remove the labels by selecting No Labels in the Style panel. In the Style settings, change Single Symbol to Inverted Polygons and change the color to a suitable blue color without any outline. For this layer, we will create a bit more advanced style by adding more style layers. Click the Add Symbol Layer button and select the new symbol layer. Change the symbol type to Shape Burst Fill. Set the first color to black with a lot of transparency and the second color to fully transparent. Change the shading style to Set Distance and try changing it to 10. Also increase blur to 17. Finally, adjust the settings for the first color so that you get a subtle shading effect around your islands. You could also try using a light color instead of black. Now let's build something on the island. We will start with some roads, but we will create them in a different way than we did when we created the land layer. This time we will create the layer directly in the GeoPackage and add attribute columns before we start editing the roads. Start by clicking the New GeoPackage Layer button or hit Ctrl-Shift-N on the keyboard. Browse for and select the previous created GeoPackage. Give the new layer a table name. I'm going to name mine Routes. Select Line as the geometry. I want to create routes of different type, like path and trail. I also want to be able to give at least some of them names. Therefore, I write Type and click Add to Fields List, followed by Name. Both should be of the type text, and if you would like to have other fields in your table, you go ahead and add them now, or you can add them later. As this is a new layer in an existing GeoPackage, you will get prompted when you click OK if you want to overwrite or add new layer to the GeoPackage. Here you should select Add New Layer. Your newly created layer may have been added under the existing layers, so start by moving it to the top of the layers in the list. Then select it and toggle the editing on for the layer. Then click the Add Line Feature button and start clicking out your first route. As before, each click with the left mouse button will add a vertex, and you finish the object by pressing the right mouse button. When you create roads, you will likely want some of them to connect to each other nicely. Therefore, we will now activate an advanced feature called snapping in Qgis. Right-click somewhere in the Tools area and activate the snapping toolbar. To activate snapping, you click on the magnet button. You can then set the snapping properties, but for now the default is fine. As you move the edit tool, it will snap to vertices that are within the set distance of the mouse cursor. This makes it easy to start a new route exactly at the existing ones. Create some more routes of different types and be careful when you type the text in the fields, so you type the same thing for routes that should be of the same type. You can give some of them names too if you would like. When you are done, save your edits and toggle editing for the layer off. To style this layer, you should use categorized styling instead of single symbol. Select type as column, and if you would like to set a default style for all types of routes, you can create that now, but the default is fine. When you hit classify, the standard is that a line will be created in a different color for each type in the attribute table. To edit the individual categories, you double-click the symbol for each and edit the style properties in the same way as you did for the land layer previously. I'm creating a simple dotted black line for my paths and a slightly thicker dashed line for my trails. There's a lot more you can experiment with when it comes to symbology in Qgis, but to cover it all in this video, it would be hours long. So for now you can experiment on your own if you like. Labels for lines are similar to those for polygons, but the placement options are a bit different. For instance, you can create curved labels along the line. Just create a reasonably simple label and try some different settings until you are satisfied. If you want to have the completed style as the default for the layer, you can also save the style like we did before. As a final layer, we will add some points. The same way as for routes, this will be created as a new GeoPackage table in the existing GeoPackage, but with the geometry type point selected. I'm just going to call this layer points, and I'll add the fields type and name as text fields to the attribute table. As before, this should be a new layer and not overwriting the previous. I'm going to add points for a lighthouse, some normal houses, and of course a treasure. If snapping bothers you, you can turn it off by clicking the magnet button or pressing the letter S on the keyboard, which will toggle snapping on and off. Save your edits and toggle editing off. This layer will also have a categorized style, where each category based on the type attribute will get a suitable symbol. Points are styled similar to polygons and lines, but there's a few more options for the type of symbols that normally can be used. My houses will be simple black squares, while the lighthouse will be an SVG marker instead of the simple marker. The treasure will be an X that I create by using the simple plus symbol and rotating it 45 degrees. For the treasure, I will also add a shadow effect by activating the real-time effects and activating drop shadow with a suitable offset and transparency. The point layer style is also saved as default style in the GeoPackage source database from the layer properties dialog. So, now is a good time to save your project. Hit Ctrl S or use the Save button. You might want to create a nice layout for your map as well. You could just export the map canvas or the map area that is shown in the main window to an image file. Just look in the project menu under Import Export. But it would be nice to add a title, maybe a scale, and some symbol explanations. To do this, you can use a built-in application for layouts. You create new or manage existing print layouts from the project menu. You don't have to give the layout a name, but sometimes it helps. The layout tool has its own window, menu, tools, and panels. The main area are your work area, where you add your layouts and work with items in these. The virtual paper can be changed by right-clicking on it and selecting properties. If your layout should have multiple unique pages, you can add any number of additional pages from the layout menu. To start with, we need to add a map item. Use the Add Map tool and drag a rectangular area for your new map item. You can resize and move this item any way you'd like, but if you want to pan the map itself, you need to change to the Pan Content tool. And don't forget to change back when you are done. If you like to change the scale, you can do that in the Map Item Properties panel. Just select the map and the panel should be activated. In the Item Properties for the map, you can change and set a lot of properties. For now, it's probably enough to add a simple frame. To create a title, you add a label item, much the same way as the map item. Use the tool and drag a rectangle. You edit the text and text properties in the Item Properties panel. To explain the symbols in the map, a symbol description or a legend can be added. As a default, every layer symbol is added to the legend. But by deselecting the Auto Update option, you can remove items and edit texts as you please. For my legend, I will not use a frame and I will remove the background as well. In order to add some sense of the size, I'll also add a scale bar and style that appropriately. To tie it all up, I add a small text explanation that could include a source reference if you, for instance, use OpenStreetMap in your product. Since my map only have my own data in it, I can decide a license for it regardless. In this case, it is Creative Commons 0, which basically means it is completely free to use by anyone. I also include a reference to Qgis, because why not? The layout can be exported to image files or PDFs, but also printed to paper if you would like that. This was a short introduction to mapping with Qgis. As I'm sure you have noticed, there's a lot more in the software that I haven't covered in this video. On the internet, there's a lot of sources with blogs, articles, training materials, support forums, and yes, more videos. Some are more specialized on a specific topic, others are more general. When you run into problems, try a simple search on the internet for the problem, and you will most likely find a solution or a suggestion. You can also post a question to something you can't find the answer to on a support forum, like Stack Exchange. You could also see if your country has a national Qgis user group. They may have additional support channels for problems of a more national character. I would now suggest that you repeat everything you have learned in this video on your own a few times. The more treasure islands, the better. If you don't remember how something was done, just rewatch the video. Also, remember to check the pages on qgis.org for documentation, as well as ways for you to take a more active part in this growing community. And finally, happy mapping with Qgis.